All right, so today we continue with lesson 8.3, part 2. Take a minute, pause the video, and solve the problem of the day. Deals with finding the horizontal asymptote. Now today we focused on graphing. We're going to still use the first 3 parts that we did in part 1, and then the new part is just adding a table to it. All right. So like before, our first plan, we had to take care of the x-intercepts, right? So x. If you think back for a second, right? Your x-intercepts were, and it might be hard to see this, oh yeah, you can see it now, it's a fraction. Think about what your x-intercepts were. Your x-intercepts come from what? The numerator. Well, if you look at the numerator, do you see how there's no variable? It would form a false statement, like 6 cannot equal 0, so x-intercepts there are none. All right. 2. What did we talk about next? The vertical asymptote. So I'm going to shorten it to VA. Vertical asymptote, I set the denominator equal to 0, right? Let's see what happens when we solve it. We get x squared equals -1. And when we take the square root, I'm just going to solve this quick here. We would take the square root of both sides, right? Square root of -1, don't forget your plus minus, but if you look, you see how we have an imaginary number? Well, if you remember from the last part, we can't have anything imaginary. So my vertical asymptote, in this case, there are none. And that's interesting because you'll see before, when we did the simple ones, you'd have one vertical and one horizontal. Now that's not the case in this lesson. That's why we spent time just doing that first example in the last part. All right, so number 3, let's keep going. We want to do the horizontal asymptote. And if you remember before, we take the degree. What's the degree up top? It's 0. Degree in the denominator is 2. All right, well, I know 0 is less than 2, so think to yourself, what do I know about the degree? If you go back to that chart, you had 3 options. This one corresponds to y cannot equal 0. So we have only one asymptote, and actually maybe I'll use a different color here. It's the horizontal one. So draw your dotted line. All right. Now, we only have one. I'm going to give you a setup for each of these to figure out if I have a problem. And when you do the problems in class, you're going to say, all right, I only have this. How many points do I need to pick? It's no longer 2 to the left of the vertical asymptote and to the right. Do you see how we don't have a vertical asymptote? So what's going to happen with this one is if you have a case with a problem with this kind of asymptote, I'm going to have you pick 5 points. Now I'm going to have you pick -2, -1, 0, 1, 2. All right, and that's what we're going to plug into the original. Now, let me move this over a little here. So here's my table. I decided to actually type it this time. You're going to plug these numbers in. Now, in this lesson, you're not going to have 4 points. You're going to have either 5 to 7 points. I don't know about you, but I'd rather use a calculator. So I'm going to give you what these points are. Make sure you could get the same numbers as me. The worst thing would be to not get, know what you're doing and not get the same numbers. So let me move this. Actually, hold on, let me try it this way. Let's start a new one here. All right. So when I plug in 2, I get 3.125. If you want to, you could round it. Then I get 4.57. Actually, hold on. Let me backtrack that. Sorry about that. I'm looking at the wrong problem. I get 1.2. All right. I get 3. I get 6. And I get 3. And I get 1.2. So let's see what happens when I plot these. Okay. So I have -2, 1.2. And we're estimating, right? Plot your points. Now, do you see how it's a bump or like a hill? Be careful, you still have a horizontal asymptote, and it always is going to approach it. So you have to extend it a little. Remember, it won't touch that line, but it's going to get close to it. Then you draw your arrows. And that's my graph. Now, domain and range, I ask you on this one. Domain deals with the vertical asymptote, and if you notice, I don't have one, right? So think there's no restriction on the vertical part or the x. So actually, you will get all real numbers. Range always is based off the horizontal, so it's y cannot equal 0 for all real numbers except y equals 0. Now, one last thing, do you see how x-intercepts is none? That means, and this makes sense, that's where my horizontal asymptote is, and if you notice, the graph will approach that line, but it will never cut through it. That's why there are none. All right, let's try another one. So here's our next one. Do the first 3 things like we did in the last part of the lesson, part 1. So x-intercepts. Set the numerator equal to 0. I divide by 2, get x squared equals 0. When I take the square root, I just get x equals 0. And that makes sense. Normally I tell you when you take a square root of something, when you solve algebraically, you have plus minus, right? But think about it, 0 is nothing. So you don't have to worry about plus minus because 0 is not a positive or negative number. So what we'll find out is when we're doing this problem, one of our points, when we use x equals 0 to cut through the x-axis. All right, so let's do next the vertical asymptote. I know I set the denominator equal to 0. Now you could solve algebraically. Don't forget that you'll have 2 answers, so you have to do a plus minus. Me personally, I just like to factor. It's the difference of 2 squares. Get x minus 3 and x plus 3 equals 0. So my answer will be x cannot equal 3 or negative 3. So I'll put my little cannot equal. So here's what's interesting about this one. You have 2 vertical asymptotes. One here. And one, 2, 3 here. All right. So this has never happened before where you have 2 of them. And we'll talk about what that means for the table after I do the third part here. Third part is your horizontal asymptote. So let's see what our degree is. The degree on top is 2. The degree on the bottom is 2. If you remember, they are equal. So how I find the y is I take the coefficients 2 divided by 1, or y cannot equal 2. Right, because there's a 1 here. So find where y equals 2 and draw your dotted line. So in this case, what changed is I didn't have any vertical asymptotes, now I have 2. Now to pick your points, I'm going to have you do 2 to the left, 3 in the middle, and 2 to the right. I know it's a lot. Like I said, the hardest part here now is just figuring that out. So if I go 2 points to the left of negative 3, I get what? Negative 4, negative 5. And then I pick 3 in the middle. I usually like to do negative 1, 0, 1. And then 2 to the left of 3. 4, 5. All right. So now we have a lot here. Remember, we're not actually using negative 3 and 3. Those are my guidelines. So once again, when it looks like this, when you do the problems, you're just going to have to take a look at where the asymptotes are and match it, the homework up to like this problem here. So once again, I do 2 and 3 then 2. Now, I will once again plug in the y's for you. Make sure you could get them. Make sure by using a calculator. You definitely don't want to do this all by hand. I mean, I know I don't. So I'm going to type them in for you. If you want to, you could even round a little bit more. A lot of times I don't. Round to like 1 digit. The whole point is you know where to plot the points, right? So let's take a look at what this means for this graph here. All right. So negative 1, 2, 4, 5. There roughly. 4, 3. So this point, do you remember how we had the branches of hyperbola in the last lesson? Well, these end pieces are going to look similar to it. They curve like this. We only need 2 points because of the dotted lines here. The middle is going to look slightly different. Now you're going to know this is like really, really small numbers here, and that's okay. That gives me enough of a model. It's going to open down. So, getting closer and closer to the dotted lines. Now we have and then connect them. Once you get enough practice, these aren't that bad. I know it's complicated at first. This is actually my graph. All right. Sometimes you'll get one like this. Sometimes you'll see, and I'll just draw a quick sketch. Say, so I'm drawing the same asymptotes here. Sometimes you'll get something like this, like how I have it. So they don't go diagonal from each other. They like mirror image almost. You might actually see something like this. And you might say, and I know in the homework you'll see something like this. The book doesn't explain it yet. You'll actually learn it in trig. You might notice that my line has cut through the horizontal asymptote. Well, there's something you'll learn in trig called a hole in the graph, like literally a hole punched out. So that would be okay, because remember, we always said they approach asymptotes, they don't cut through them. You'll see a couple of these like on the homework packet, but you don't have to worry. Like if they cross through, it's okay. You'll learn more about that at a later date, like I said in trig. And honestly, I don't think you want me to elaborate more than what you need to, right? So that's just a little thing to mention too. Sometimes they'll look like that, sometimes they'll open down, sometimes they'll open up. All right. So let's do the last one. Same thing again here, number 1. Intercepts. Just set the numerator equal to 0 again. We're going to factor, get x minus 1. Now, it's the same thing twice, so honestly, I'm just going to write it once, get x equals 1. One thing I want to mention about the x-intercepts, I'm going to go back for a second. Do you see my x-intercept is 0? So at 0, the y will always be 0. Or whatever number it is, the y will be 0, which is here. So it did cut through my x-axis there, and that was it. If I go back for a second, you saw that it didn't cut through anything. Now with this last one, you'll see that it'll cut through the point here, where it's 1, 0. And we'll see that once we graph. All right, step 2, vertical asymptote. Get negative 2. So find negative 2 here. Draw your dotted line. All right. Let's do the horizontal asymptote. Once again, we do the degree. So my degree up top is 2. My degree on the bottom is 1. We have it as greater than, right? So if you remember, if it's greater than, there is no horizontal asymptote. There's none. So here's the other scenario you're going to see in the homework and in the problems from this lesson. We'll have one dotted line. When that's the case, we're going to use, do you remember how when we had a vertical line, we would do 2 to the left and 2 to the right? Once again, I don't have 2 lines that are asymptotes, I have 1. So what we're going to have to do is do 3 to the left and 3 to the right. So I have negative 2, or I have 2, right? So I'm going to want to do 1, 0, negative 1, negative 1, 0, 1, and 3, 4, 5. And if you remember, oh, Alright guys, did you notice one thing real quick that I just did and I just erased it? It's -2, not +2, so give me a second here. We gotta change your points. So sorry about that. We'll go back. So I'll start here again. Alright. So -2 is here, right? Do not do +2 like I just did. I mean, it's an easy fix. Now we want 3 points. I said not 2 because there's only one dotted line. There's not 2. So we want 3 points to the left, 3 points to the right. So if it's -2, -3, -4, -5. -3. And then we want, after -2, we want -1, 0, 1. All right, that's a lot better. Remember, we can't actually use -2. So we're picking 3 points to the left, 3 points to the right. Like I said before, once you practice these, we have 2 worksheets that we practice graphing on. You'll get better at it. You just got to see what kind of situation we have. All right, so let me type in our numbers. Now my numbers are going to be a little off here. The chart, but let's see what we get. We get -12. Then we get -12.5, -16. Then I get 4, 0.5, and 0. Now when I plot, what I'm going to do, because I only go by 8s here, is I'm going to do, let's say I need 16, right? I'm going to go by 2s for everything. And then this way I'll go by 1s. So the y is where I need more. All right. So 1, 2, 3, 4, 5, -12, 2, 4, 6, 8, 10, 12. And the next one's 12.5, about here. And then 12, 14, 16 is here. So what's going to happen with this is it starts like getting close here, then it curves outward like this. Actually, let me draw that a little bit. Sometimes it's hard to draw with a mouse here. So it's more like this. So you can't do 2 points because you wouldn't know that there's more of a curve, and I'll give you a little better explanation in a second here. You have -1, 4, 0.5, 1, 0. Now do you remember I said the x-intercept is at 1, 0? Well, in fact, we do see that. So it gets close to this asymptote, and it curves and shoots out. So here's how my last final graph will look. Now, if you're wondering, why does it look like that? There's another thing you'll learn in trig that we don't talk about, and I'm sure you're okay with that because this is enough to remember. But right here, do you see this diagonal where I'm moving my pen? That's a diagonal asymptote. There's another asymptote that you'll learn in trig why it does that, but for our purposes, you don't need to know that. All right, that's it for the lesson. Homework is the problem of the day, and on assignment 4, I only want you to complete number 10. I want you to give it its best shot, so when we come to class, we can go over it.